Creating and solving proportions. If two figures are similar, then the corresponding parts are proportional to each other. So let's do an example of similar triangles, and then in the next examples we're going to make our own similar triangles. So the first thing we're going to note is triangle ABC is similar to triangle DEF, and we have a few of the sides. So the corresponding sides would be right here, and then right there, and finally right there. Okay, so we just set up a proportion using those. So for if I want to find AC, we'll call it X right there. We're going to find X. So we're going to use something that we have both of. So we have 16 and 12 on a corresponding side. So I'm going to put 16 over 12, and that's going to be equal to X over 18. Make sure that we have the first triangle on the top and the second triangle on the bottom. That's one way you can do it, or you can stack them both up on the same fraction. Make sure you keep them lined up like that. Alright, then I'm just going to solve, so I'm going to cross multiply and divide. What I'm going to have is 12x equals 16 times 18. So 12x equals 288. And finally, we divide by 12. And x equals 24. So to find AC, we would find x to be 24. So for this next one, we want to find DE. Okay, so we're going to call this Y up here, and we're going to find Y. So again, we're going to need to set up the corresponding parts. So we have the 10 and the Y, and we can use the 16 and the 12. Okay, so if we stack them up, the first triangle, we have 10 over Y. Those are corresponding parts, and that's going to be equal to 16 over 12. So I have the first triangle on top and the second triangle on bottom, corresponding parts of each going down. So I'm going to cross multiply. And that's going to give me 16y equals 10 times 12. So I have 16y equals 120. Then I divide by 16. And y equals 7.5. So DE is 7.5. And that's your final answer. In this next example, we will be applying similarity to shadows. Suppose the sun's rays strike a building and a girl at the same angle, forming similar triangles. The girl is 5 feet tall and casts a 3-foot shadow. The building casts a 15-foot shadow. How tall is the building? So if we start by drawing a picture, the girl is 5 feet tall and casts a 3-foot shadow. The building casts a 15-foot shadow, but we do not know how tall it is. Okay, so it's a length or a height, and we'll call it X. So here we have our similar triangles, so we can set up a proportion. So we have 5 over X equals 3 over 15. So I have the girl triangle on the top, and then I have the building triangle on the bottom, and I made sure that the corresponding parts were lined up. Okay, so I'm going to cross multiply, giving me 3 times x equals 5 times 15. So what that gives me is 3x equals 75, and then I divide by 3. So my final answer is x equals 25. What does this mean? This means that the building is 25 feet tall. Okay, so make sure you can explain what all that means. Building's 25 feet tall. In this next example, a 6-foot tall man is standing next to a flagpole. The man's shadow is 3.5 feet and the flagpole shadow is 17.5 feet. How tall is the flagpole? So again, I'm going to set up some similar triangles. The man is 6 feet tall and he casts a 3.5 foot shadow. So there's one triangle, and then I have the flagpole that we don't know how tall it is, so it's got some height, but we do know that it casts a 17.5 foot shadow. So I can set up my proportion 3.5 over 17.5, and that's going to be equal to 6 over h. Okay, so it doesn't really matter where you set them up as long as you're careful that one triangle is going here, and so that's the man triangle, and then here's the flagpole triangle, and then I have the corresponding parts lined up and down. So now I just have to cross multiply, so I have 3.5h equals 6 times 17.5. So I'm going to use my calculator to solve that part, and I get 3.5h equals 105. So I'm going to divide by 3.5. So I get h equals 30. So what does this mean? This means that the flagpole is 30 feet tall. Okay, so make sure you can explain what number is that you found. And that's all you have to do. Now we're going to be applying similarity ideas to scales on maps. So suppose that a scale on a map is 1 inch to 110 miles. So I'm actually going to start with that. 1 inch to 110 miles. What is the actual distance from Jacksonville to Orlando if the distance on the map is 1.25 inches? Okay, so the map was on top. Okay, so if the map is on top, then I have 1.25 inches on top because that was the map, and I don't know the actual distance. So I'm just going to write x miles. Alright, then I'm going to cross multiply and divide, so I have 1 times x, which I could just say is x, equals 1.25 times 110. And then I need to just type that into the calculator. So x equals 137.5. And what does that mean? That means that the distance from Jacksonville to Orlando is 137.5 miles. And that's your final answer. And the last example is another one with scales. And we're going to use the same scale of the map, 1 inch to 110 miles. And the distance from Jacksonville to Gainsville is 0.6 inches. And we want to find the actual distance. So I'm going to put 0.6 inches on top because that's my map row. And then below that I don't know the distance, so I'm just going to put x miles. And then I solve by cross multiplying, so I have 1 times x equals 0.6 times 110. And then I can type that into the calculator. And I would get x equals 66. So what does that mean? That means that the distance from Jacksonville to Gainesville is roughly 66 miles. And that's your final answer. So those are your notes over creating and solving proportions if they're like as word problems. So you should be able to do some of these practice problems and then take your quiz over this material.